Hey, look around the room you're sitting in right now. Like, really look. What do you see? Maybe a rectangular door, a square window, or a circular clock on the wall? Our entire physical world is literally built from fundamental two-dimensional shapes. And today, in this explainer, we're going to master the math behind them. Okay, let's dive right into this. We're unpacking a fantastic little resource from Universidades Muhammadiyah Sido Arjo. It's affectionately known as the Buku Saku, or the pocketbook of math secrets. Basically, we're going to take these formulas off the page and turn them into mental tools you can carry around in your head anywhere you go. Here is our study map for this session. We'll start with perimeter and area basics, then hit squares and rectangles, uncover some triangle secrets, explore trapeziums to kites, and finally, tackle circles before our ultimate boss battle with combined shapes. All right, Section 1. Basic concepts of perimeter and area. Because, hey, we've got to understand the rules of the game before we start playing, right? So the absolutely crucial point here is understanding the difference between perimeter and area. Imagine a yard. The perimeter? That's just calculating the total length of the fence you'd need to build around the outside. You just add up the outer edges. The area, on the other hand, is the grass. It's calculating the total amount of space that fills the inside of that shape. So fence on the outside, grass on the inside. Got it? Awesome. Moving right along to Section 2, measuring squares and rectangles. Let's go meet the quad squad. Notice how beautifully simple these foundational formulas are? Take a square. Because all its sides, which we call S, are perfectly equal, the area is just side times side. And the perimeter? Just multiply that side by 4. Simple. For a rectangle, it's slightly different. The area is length times width, and the perimeter is 2 times the length plus 2 times the width. Clean, categorized, and super easy to memorize. Now, you might be wondering, why does this actually matter? Well, imagine you're renovating a house. You've got a perfectly square room with 6-meter sides, and you want to lay down square ceramic tiles that measure 40 centimeters by 40 centimeters. How many tiles are you actually going to need to cover that floor? See, this isn't abstract math anymore. This is literally your weekend DIY project. Let's crack this puzzle together. Step 1, we absolutely need matching units. So convert that 6-meter room side into centimeters, giving us 600 centimeters. Step 2, figure out how many tiles fit along just one single edge. Well, 600 divided by the 40-centimeter tile means you can fit 15 tiles per side. And step 3, apply our trusty square area formula. Side times side. 15 times 15 equals 225 total tiles. Boom, you just used geometry to buy the exact right amount of flooring. How cool is that? Okay, Section 3, uncovering triangle formula secrets. Time to hang out with the pointy crew. All right, rapid-fire speed round to identify our triangles. Ready? First up, the equilateral triangle. Totally balanced, 3 equal sides, all angles are 60 degrees. Next, the isosceles. It has just 2 equal sides, kind of like a tall, pointed tent. Then, the right triangle, the absolute classic featuring a perfect 90-degree corner. And finally, the scaling triangle, the rebel of the group where literally all sides are different lengths. So the crucial point is how we actually measure these pointy shapes. The perimeter is a breeze, honestly. Just add up all 3 sides. But the area, that requires a specific formula. 1/2 times the base times the height. And remember, the base is your horizontal foundation, and the height must be strictly vertical. It has to stand straight up at a 90-degree angle from that base. Let's put that into action real quick. Imagine an isosceles triangle with a base of 10 centimeters and a height of 12 centimeters. Step 1, identify those 2 numbers. Step 2, multiply the base by the height, so 10 times 12 is 120. Step 3, and please, whatever you do, don't forget this part, divide by 2. 120 divided by 2 gives us an area of 60 square centimeters. Easy, right? You're doing great. Moving to Section 4, polygons, from trapeziums to kites. Don't worry, these are just slightly fancier variations of what we already know. Grouping these advanced formulas visually is a fantastic way to help your brain naturally categorize them. Look closely. Notice how the kite and the rhombus actually share the exact same area formula? Yep, it's 1/2 times diagonal 1 times diagonal 2. The parallelogram is just base times height, exactly like a slanted rectangle. And the trapezium? It just takes the average of the top and bottom parallel sides, labeled A and B, and multiplies that by the height. I want you to imagine this practical challenge straight from our source text. Pak Burhan has a garden shaped exactly like a right trapezium. The two parallel sides are 15 meters and 21 meters long, and the straight vertical distance between them, so the height, is 12 meters. So, how big is his garden? Let's break that scary-looking trapezium formula into bite-sized pieces. Step 1. Add those parallel sides together. 15 plus 21 is 36. Step 2, divide that by 2 to find the average, which is 18. Step 3, just multiply that by the garden's height of 12 meters. 18 times 12 gives us 216 square meters. Boom, garden problem solved. See? Formulas aren't intimidating at all when you just take them one step at a time. Finally, Section 5, Circles and Combined Shapes. We have reached the curved world, folks. Time to gear up for the final stretch. And this brilliantly illustrates how curves really do have their own special math language. A circle has a single center point. The constant distance from that center to the edge, that's your radius, or r. The diameter is the full distance straight across, which is just twice the radius. To find the area, you use that magical number pi times the radius squared. And for the perimeter, which we call the circumference, it's 2 times pi times the radius. Okay, this is it, the boss battle. We are tasked with calculating the total area of a combined shape. It consists of a rectangle measuring 20 by 9 centimeters, and attached right to the top of it is a triangle with a base of 18 centimeters and a height of 8 centimeters. Take a deep breath. Combined shapes might look complex, but honestly, they simply require using the individual building blocks we've already mastered. Let's conquer this level by just splitting the shape in two. Step 1. Calculate the area of the rectangle alone. 20 times 9 equals 180 square centimeters. Step 2, calculate the triangle sitting above it. 1/2 times the 18 base times the 8 height. Well, half of 18 is 9, and 9 times 8 is 72 square centimeters. Step 3, for the grand finale, just add those two separate areas together. 180 plus 72 equals 252 square centimeters. You did it! No way, that's awesome. You successfully took a seemingly complex, abstract shape, broke it down into its fundamental parts, and calculated the exact area. Give yourself a massive round of applause for sure. You have officially mastered the formulas in our digital pocketbook. But hey, the learning doesn't just stop when the screen turns off. So I have one last challenge for you. Look around your room right now, just like we did at the very beginning. Spot one 2D shape, maybe a TV screen, a rug, a picture frame. Think about which formula from our Buku Saku you would use and how exactly you would calculate its area. Take these new mental tools off the screen and into the real world. I promise you'll never look at a simple room the exact same way again. Thanks for hanging out with me on this explainer, and keep exploring.